Hello, my dear students. I hope you are doing well in your flying training and ground training and spending sufficient time. And you always run short of time, no doubt about it. And some of my old students who have been with me, attended my classes, have recommended that I make some videos for quick revision, last minute revision, fast revision. Okay, I understand everything is fast nowadays, including food. People don't have time, fast food. Okay, today we'll do a fast revision of gyro numericals. In lesson number 14, I had done fast revision of the instruments. Now, how do we do it? Quick revision, last minute. Examination is approaching very fast. Right. Remember these formula or equations for your gyros. Number one, let's tackle turn coordinator or turn and slip indicator. And the numericals are sometimes asked regarding what should be your rate of turn. I beg your pardon, bank angle, theta. Your bank angle should be true wave speed by 10 plus 7 degrees for rate 1. If your true wave speed is 180, 18 plus 7, 25 degrees should be your bank angle for a rate 1 turn, which means 180 degrees per minute or 3 degrees per second. Also called standard turn. Rate half standard is 1.5 degrees per second. And rate 2 is 6 degrees per second, and so on. Some of the possible numericals are that the aircraft is turning left or right. What will be his rollout heading? Okay, we am at position A in the direction of 030. If I'm turning right by 60 degrees, add 60, I will roll out at 090. And if I'm turning left from A towards T by 90 degrees, then my rollout heading will be 030 minus 90. So 030 now I can write it as 390. Minus 90, I will say 300. And he says from this position, see, you are turning towards direction of B, 090. It will be a total of 150 degrees turn, 300 plus 150. To the right, I will add. My answer will be 450, and 450 can be rewritten as 090. Okay, next question could be, he says you are making this turn from 030 towards left up to 300. How much time will it take? Find out total turn, 90 degrees. Okay, and if it is rate 1 divided by 3, I will say 30 seconds, rate 2 divided by 6, 15 seconds, and rate half, 1.5 degrees per second, 60 seconds. These are some of the questions asked in turn coordinator, turn and slip indicator, and now you find out how simple they are. Regarding directional gyro indicator or gyro heading indicator, which gives you direction with respect to the gyro north. Gyro north is a point in the space where you make it point and will not move, whereas your magnetic north will move. Okay, because the meridians are moving and magnetic north is taken from a meridian. Question on topple, 15.04 into cosine of latitude per hour. Questions on DGI are regarding gyro drift, also called wander, And when it's a stationary aircraft, it is called apparent wander due to Earth rotation. Because these meridians move in space, gyro keeps on pointing towards the same direction. And therefore, in the northern hemisphere, gyro readings decrease compared to magnetic compass readings in northern hemisphere and increase in southern hemisphere compared to your magnetic compass readings. Okay, numericals for DGI, either he could just ask you what will be the apparent wander for an aircraft, stationary aircraft at this place. That is only step number 1. Find out where you are. If you are at 60 north, your apparent wander will be 15 into sine of 60, and it will be per hour. In the northern hemisphere, write down readings will decrease, and if you are at south, write down readings will increase. Now let's do a numerical in which it's called a balanced gyro, in which you have set the latitude knot. If you set the latitude knot also at 60 degrees north, then your net wander is 0. But if you have set it at anywhere else and you're flying on some other latitude, then there will still be a remaining or net wander. And gyro knot, latitude knot creates a real wander. It actually moves a gyro axis. 15 into sine of latitude per hour. In this case, he set the latitude at 45 north. For 15 into 0.71, I've taken it up to second decimal. 10.65 degrees per hour increase given by the latitude knot. Okay. If both these are decrease, add them up. Both these are increase, add them up and write down increase or decrease as relevant. But if one of the values is decrease and other is increase, then find out the difference. In this case, 2.40 degrees. Since decrease is more, I will write down 2.4 degrees per hour decrease. Supposing he has set the latitude knot to 45 south, balanced, gyro balanced at 45 south. A will remain same because the aircraft is at 60 north. Latitude knot has been set to south, so it will also decrease the readings now because you have set it to south. Now my net wander will be 23.7 degrees per hour, and it will be decrease because both are decrease. Okay, now I have tried to make it as short as possible. You can practice some numericals, and if you need any help, you can put that numerical in the comments. I will give you help. This is for CPL level. For ATPL level, they also include a transport wander, for which we need some more knowledge, that is of maps and charts. That I will do it on a separate lesson. Okay. Now, for the time being, as I promised to keep it short and sweet, I will sign off here. And you want me to put some more videos of this type, don't forget to like and subscribe, and also the bell icon, so that you keep getting the notifications. More the number of likes, more the number of questions I will keep on putting up. That means it is benefiting the community for which I have prepared. And don't forget to share it with your friends also. Booty here, SK Booty, signing off for the day. Bye-bye.